Hi, I'm Jessica. I'm a tutor here at Chegg.com. Today we're going to be talking about amplitude and period in terms of trigonometric functions, specifically sine and cosine. So the first thing I want to look at is the generic formula for sine and cosine, where we have f of x equals a sine of b of x, where a will represent the amplitude and b will help determine the period. To determine the period, we'll have 2 pi, and we're going to divide by that coefficient of x, the b. So the amplitude is specifically the coefficient in front of sine or cosine. So if we look at our parent graphs, f of x, sine of x, you'll notice that the coefficient of sine would be a, which would be 1 in this case. So it has an amplitude of 1. Now, what is amplitude, you might ask? So amplitude is the height of the graph from the crest or trough to the inflection point. That is the point where it changes from increasing to decreasing. So in this case, from the crest to the inflection point, this would be the height. So in our sine graph, our parent function, it would have an amplitude of 1. So I would cosine, as there's no coefficient in front of the cosine. On the sine function, also notice there is no b, so the coefficient of x would be 1. Also the same with cosine. Therefore, you would have 2 pi divided by 1, which would be 2 pi. So the period for both sine and cosine, the parent graphs, is 2 pi, which means that each sine and cosine go through one cycle of their graph before completing a no cycle within 2 pi. Okay, so let's take a look at a couple of these and see how we would determine the amplitude and period when giving a couple of problems. So for on the first one, if you notice, there's no coefficient of sine, so that means the amplitude in this case, and I'm just going to represent that with an A, would be 1. And the period, I'm going to note that with a P, would be 2 pi divided by 4, because 4 is the coefficient with the x. And if I reduce this, I would get pi over 2. So pi over 2 in this case would be 1 cycle of the sine graph. Okay, so basically what we're having is a shrinking of the graph versus where if this number would have been a fraction, it would have been an enlargement of the graph, believe it or not. Okay. Generally, this is what I try to remember. If a number is occurring outside of the function, it's happening vertically to the graph, and also it's very straightforward. So if it's 1 or 2, it's twice as large. However, if it's happening inside the function, it's happening horizontally to the graph, and generally it's the opposite of what you see. So if you see a larger number, it's actually shrinking the graph versus a fraction where it makes the graph stretch out. Okay. Cosine, notice we have a coefficient of 1 again, so it has an amplitude of 1 and a period of 2 pi over 5. Now that can't reduce, so we're just going to have 2 pi over 5 as the answer. Okay, so number 3 is our parent function, which we've already discussed. Number 4 would have an amplitude of 4 because it has a coefficient of 4 in front of the cosine. And then there is no b, or coefficient of x, so our period in this case would be 2 pi. Okay, here we have a coefficient of 2, and the amplitude will be this absolute value. So the amplitude will be 2, not -2. You can't have a -2 as a height. Okay, so the amplitude is 2, and because this is, there's no b here, we also have a period of 2 pi. Okay, so let's look at something that has both in there where we're making 2 changes. So in this case, the amplitude would be 2 because we have a coefficient of sine of 2, and then the period would be 2 pi over 4, and it's not -4 because once again this should also be absolute value because we cannot have a negative period. It's not going to go backwards or anything crazy like that. So 2 pi over 4 reduces to pi over 2. Okay, let's look at this one that has a fraction in it. So in this case, the amplitude is 3. Pretty straightforward here, I think. And however, the period is going to be a little tricky because it is 2 pi over 2/3. If you remember, when we divide by a fraction, we're multiplying by the reciprocal or the multiplicative inverse, and therefore, actually, we would end up with 6 pi over 2. Which reduces to 3 pi. So this has a period of 3 pi. Okay, let's look at some graphs and determine the amplitude from the graph. So the amplitude can be determined from a crest to an inflection point or straight to the horizontal axis in this case because it is centered. But if there's any kind of shift in the graph, you can't do it like that. So I always like to go from the crest to the inflection point in this case. And if you'll notice, it has an amplitude of 3. The amplitude is 3 here. And the period, a good way to think about the period is from either crest to crest or trough to trough, or once it makes one cycle. So in this case, one cycle, let me change color so you understand what I'm talking about. One cycle, assuming this is sine and there hasn't been any kind of horizontal phase shift, it would make one cycle within pi. So the period here is pi. Okay, here we have an amplitude of 4, because if you notice it goes from 4 to the inflection point, so the amplitude is 4. We have a period of 2 pi. So the amplitude is 4, and we have a period of 2 pi. Okay, I like to borrow material, so this worksheet was borrowed from this website. I always find that it's easier if I find a worksheet to write on versus me drawing it out and taking longer for the person I'm tutoring. So I always like to go find something that's already available. I do like to give credit for everything I borrow, so this is a borrowed worksheet. The amplitude for this graph, in this case, would be 2. And one cycle of this graph would be 4 pi. So the period is 4 pi. Okay, last but not least, this one. So we have an amplitude of 5, if you notice, from the crest to the inflection point. We have an amplitude of 5. And a period of 2 pi. Hey, I know that the worksheet said write an equation of each graph, but I'm just showing the amplitude and the period because this is really what this video focuses on. If you would like to know more about amplitude and period in terms of trigonometry, please do not hesitate to send me a message at Chegg.com on this following website. Thank you for listening to me today.